Dear students, today we're going to cover the topic variations. There are two types of variations in mathematics and also in real life. A variation can be a direct proportional variation or an inversely proportional variation. So we have two variations, two types of variations. These can be either direct, so directly proportional, or inversely proportional. Let me give you some practical examples. For example, direct variation. You are paid at the rate of €7 per hour. This means that the more you work, the more you're paid. That is a direct variation. If one increases, the other increases. You increase the number of hours of work, you increase your paycheck. On the other hand, inversely proportional. For example, 5 men take 20 days to finish a job. What does this mean? This means that increasing the number of men on the job will decrease the time taken to finish the job. Here we have an inverse variation. Increasing one variable decreases the other variable. It could have been the other way around, okay? Decreasing the number of men, it will increase the days to finish the job. So these are direct and inverse are our two types of variations. Now, in mathematics, we find the symbol for proportionality. Symbol of proportionality. The symbol of proportionality is this symbol here, okay? And that symbol stands, we could write down equals a constant instead of it. So, how we are going to use that symbol? For example, I tell you x is directly proportional to the square of y. How do I translate that sentence into a mathematical formula? So we're saying that x is directly proportional to the square of y. But I said a few seconds ago that this symbol is equal to k. So x is a constant times y squared. X is a constant times y squared. So that's what it means. Let me give you another example. Suppose I say that P is inversely proportional to the cube root of Q. Suppose we have that sentence. So, what does that mean? X proportional to the inverse, because inversely to the inverse of the cube root of Q. So that is in symbols. To form a formula, so x is k times 1, so that's k on the cube root of Q. Okay? So that is my formula. Okay? That's my formula. Now, when we have these types of problems, the first thing we need to find is the value of k. K is a very important value, has a very important value, which we need to find to be able to use that formula. So now I'm going to do various examples where I'll be showing how to find K and then how to use that formula. So for example, if X is directly proportional to the cube of y and x is 27 when y is 1, find the value of 1, x when y is 100, 2, y when x is 64. So I'm going to start by describing that, okay, by describing that x is directly proportional to the cube of y. So x is directly proportional to the cube of y. So x equals k y cubed. So that is the relationship between x and y. Now, using this part, I am given that part to find the value of k. So x equals k times 1 cubed. So k is equal to 27. So the relationship between x and y is x equals 27 y cubed. And that is our relationship. Now, finding that relationship will help us to solve the problem number 1 and number 2. So, number 1, find x when y is 100. X is equal to 27 times 100 cubed, because now I can use this equation. So x is equal to 27 million. That is the first answer. Number 2, find y when x is 64. So 64 equals 27 y cubed. So 64 on 27 is y cubed. Then y is the cube root of 64 on 27, which is 4 on 3, or 1 and 1/3. And that is the value of y. That's our first example. We'll work out a few other examples. Another example on the way. So example, if b is inversely proportional to the square of m and b is 9 when m is 25, find 1, an equation relating b and m. 2, the value of b when m is 4, 3, the value of m when b is 144. So that is our problem. This time it is an inverse proportion problem. So we're going to start by finding an equation relating b and m. So as we did in the other problem, we're going to start by describing that. All right? If b is inversely proportional to the square of m. So that is our problem. So b is equal to k on m squared, and we're going to use the second part. B is 9 when m is 25. We're going to use that to find the value of k. So b is 9 when m is 25. So k is 9 times 25 squared. You're going to use your calculator to find 9 by 25 squared, which gives an answer of 5,625, and that is k. So, first part of the problem is solved. B is equal to 5,625 over m squared. Now we need to find the second and the third part. So second part, find the value of b when m is 4. So b is 5,625 divided by 4 squared. That gives a result of 351.6. Part 3, find the value of m when b is 144. So I have 144 is 5,625 on m squared. So m squared is 565 over 144. So m is the square root of 565 on 144, which gives a value of 25 on 4, or 6 and 1/4. So that's about variations. Those are direct and inverse variations. Okay? Thanks for your attention.